The universe has come a long way since the explosive chaos of its early years, much of it having become relatively ordered, as in our own Milky Way, where billions of cosmic bodies now rotate along given trajectories, rarely intersecting with other objects. In our solar system, each planet is the unquestioned master of its orbit, in which the probability of colliding with strangers is negligible, except for inconsequential little nothings like comets or asteroids. But we cannot be completely sure that such a situation will continue forever. If the Earth hasn't recently encountered any obstacles, say in the form of another planet, it doesn't mean that it won't happen. Even in the relatively small orbit of our Earth, with its length of about 940 million kilometers, there actually is more than enough space for several cosmic inhabitants. The main obstacle to this is gravity. Due to this ubiquitous force that reaches across the entire universe, the interaction between two competing planets in one orbit could result in one of them being thrust inwards, falling into the sun, or conversely, with one of them getting shot out and departing our solar system altogether, eventually flying billions of kilometers out into the cosmos. In addition, there's another, equally impressive possibility. Both cosmic bodies could unite in a mighty collision, from which light and thousands of fragments would scatter out into the vastness of space, and even into the reaches beyond our solar system. However, we have no need to wait to see what would happen. We can observe the results of such a collision right now. It was due to the tremendous impact of another object into the early Earth, our humble third planet from the Sun, that our moon appeared. This impact also resulted in our world acquiring a surface very close to its modern-day one. So we and our moon are the result of a collision of two massive objects on intersecting trajectories. Astrophysicists have calculated that this event occurred rather quickly and unfolded in a gloriously epic fashion. That said, things don't always end up this way. Sometimes space bodies can coexist peacefully in the same orbit for billions of years. But this is possible only under certain conditions. The interaction of a planet with the sun creates 5 special zones called Lagrange points, peculiar gravitationally dead regions where gravity essentially stops working. Gravity is, in effect, canceled out in these spots, a kind of null point balanced precisely between the two bodies. Therefore, another small planet could be placed in orbit around the parent star in such a region, and could quietly revolve around the star endlessly, never having to worry about being ejected. However, in actuality, there are only 2 of these points that are stable. In the others, the cosmic body has dimmer prospects: a fall into the sun, a collision, or migration into the outer reaches. In fact, in one of these safe areas, an asteroid has joined the Earth in its orbital plane, and for billions of years has accompanied our planet in its journey around the sun. This might give us a reason to enter into a wild hysteria about the potential end of the world, or could inspire legends of a second moon. However, the rotational trajectories of the Earth and its companion are still different, in spite of the fact that they intersect and are practically duplicates of each other. Anyhow, in most other cases, the chance of 2 objects sharing one orbit are not so great. That is, unless we aren't talking about 2 of the satellites of Saturn, Janus and Epimetheus. In this variation of the theme, the situation has developed much more originally. It's really quite something. These 2 satellites of Saturn are orbiting in 2 different horseshoe-shaped orbits, but Janus and Epimetheus exchange orbits every 4 years. And this has been happening for several billion years now, with the 2 space bodies never having ever faced each other. Astoundingly, the 2 objects in fact followed just one identical trajectory, only at different times, while their companion is far, far away. This example is a bit different from what we're looking for, but in 2011, research scientist Jack Lissauer found exactly what we're looking for. In the KOI 730 system, 2 planets of the 4 so far detected at that point appeared to actually rotate in precisely the same orbit. These wonderful examples, it was believed, made a complete revolution about their star in just 9.8 days. Such a unique phenomenon in the universe is possible precisely and only because of the Lagrange points discussed earlier. Of course, the researchers calculated the possibility that these planets might suffer the fate of a fatal collision, but they said not for at least another 2.2 million years. But can you believe it? The discoverers of this miracle system later disavowed their earlier research. These Kepler mission scientists said that they'd screwed up their initial calculations and withdrew all of their scientific articles on the topic. However, this hasn't prevented the story of this strange orbiting pair from roaming the internet, misleading millions of amateur astronomers and space aficionados. But perhaps the weakness of our theory so far is that we're limiting the number of bodies involved. What would happen with 3 or 4 planets in the same orbit? Or heck, let's consider what would happen if we moved each and every planet in our solar system into the orbit of the Earth. What in the world would happen then? Let's assume that this amazing set of circumstances has come to be. Every planet, from tiny little Mercury to the far distant Neptune, has suddenly settled at a distance of 1 astronomical unit from the Sun. And each planetary body is also equally distant from each of its neighbors. Could mankind even survive in this unique situation and witness the result of this vast and amazing interplanetary get-together 100 years from now? At first, the planets will attempt to rotate together along a single trajectory. But as in any overpopulated living space, the neighborhood soon becomes unbearable. Within a year, the former cohabitants will begin to separate and go their own ways as they revolve around our yellow dwarf sun. Among other things, the configuration of the planets in the solar system that we enjoy at present will never again return. And we will, obviously, no longer be able to call our planet the third from the sun. The Earth will actually now be first in rank, periodically giving way to Uranus, which, due to its elongated orbit, will now and then change position from the first to the last. Another result of this cosmic jamboree, our planet will soon move more than 30 million kilometers closer to the Sun. Because of this, the average temperature will quickly exceed 60 degrees Celsius, which is several degrees higher than the highest temperature ever recorded on Earth. Such an infernal heat will, in general, reduce the likelihood of many kinds of life surviving. Regardless, it'll be more than enough to rapidly reduce biological diversity. Only the most heat-resistant species, and those humans who have enough very strong air conditioning, will survive. Those not overcome by the blistering hot air will be finished off by an almost absolute absence of water. Most of the precious H2O that's left in the solar system will be on Neptune and Uranus. But, alas, it would take too much time to get to either of the planets, and besides, the quality of the local water in those places leaves much to be desired. Interestingly, the Earth year will be reduced by 159 days, as under these new conditions, our planet will take just 206 days to make one complete revolution around the Sun. Gravity will also increase, but it's unlikely that it'll keep you in your chair in front of the computer more than a video from your pal Riddle does. The other planets will be facing their own difficulties. Neptune will be thrown out beyond the edge of our galaxy and is unlikely to ever return, no matter how much we might yearn for it. Something similar will happen to Mars, the one planet humanity hoped to colonize in the near future. The red planet will leave the solar system to remain forever alone, and so we'll have to look to some new option for colonization. It'll eventually be almost impossible to establish an order of the planets, who goes after whom, as too often the orbits will intersect with each other and cross in this discombobulated scenario. However, there's a possibility that this whole cosmic bacchanalia could play out differently, perhaps even more pessimistic for the third planet from the Sun, or perhaps less so. The fact is that such calculations are performed on supercomputers with the help of specialized programs that may not properly take into account all of the variables. In the interplanetary insanity described here, the objects were initially located at a strict equal distance from each other, in the order that we're already familiar with from our school days. But change only one little parameter, and who knows, maybe our planet will be ejected from the solar system instead of Neptune, to be sent billions of kilometers away, and maybe even eventually into another galaxy. Or the gas giants, with their tremendous masses, might destroy all of the small rocky planets, reducing them to but tiny little fragments and dust. To give an example, if you added Pluto into the list, which was, once upon a time, considered a planet, and squeezed it in with all the other planets in this overpopulated orbit, calculations suggest that the Earth would be thrown in a completely different direction, with the temperature dropping to that of the permafrost, eventually turning the entire planet into something like a single glacier. Fortunately, the likelihood of a circular dance of all the planets of our solar system in one orbit is so negligible as to be close to zero. Almost all such cases in the universe take place in the first few millions of years after a solar system is formed, and resolve themselves through monstrous collisions of objects in intersecting flight paths. Even more, the presence of an additional cosmic body of a planetary mass in the orbit of another planet contradicts all existing astronomical rules. For all intents and purposes, a planet is generally considered an object which has already, long ago, completely cleared its orbit of most interlopers of consequence. This can be observed in planetary gravitational calculations. Massive giants generally push everything out of their way, eventually ending up on a discrete trajectory around their parent star as a result. Therefore, if a planetary interloper were to enter the same orbit as the Earth around the Sun, most likely we'd lose our status as a planet until the stranger was displaced, or until we ourselves would leave our orbit, falling into the embrace of our parent star, the Sun. But whatever the calculations are, the Earth almost always comes out as the one planet where there is at least the slightest chance of our continued existence. No matter how much we dream of colonizing other planets, solar systems, and maybe even one day galaxies, the best place in the universe that we know of is here, no matter how pompous it may sound. Our task, then, is to preserve this earthly life as best we can, as despite the vastness and immensity of the cosmos, as of now, there exists for us, and all life as we know it, only this place, our home, third planet from the Sun.